Hi, this is Kevin Trainer, and welcome to part one of my lecture for chapter 6 of the third edition of the John Zelle Python programming book. Chapter 6 is on defining functions. So let's get started. Normally, I don't go through the objectives. I leave those for you to read on your own. Okay, so we dive right into it here with a slide called the function of functions. So in previous chapters in the book, okay, most of which we've covered, we've been using functions as we've been going along. So in our programs, for the most part, we've been able to get all of our logic into a single function called main. And we've come to understand that having a top-level function in our program called main that contains the kind of controlling or summarizing code for the entire program is a best practice in Python. We've also learn how to use some of the Python built-in functions, including print and abs to get the absolute value. And then we've also learned that there are functions available from the standard libraries, which are part of Python, but typically require us to add an import up in the top of our code in order to get access to that part. And a good example of that was the square root function from the math package. Something that we haven't done in my course is the last example on the slide is to use the getX from the graphics module, because we don't cover chapter 4 in my course. So why do we need functions? Okay. Well, we use them to organize our code, right? And then we're going to find out there's lots of other little goodies that are available with functions, some of which we've taken advantage of before, probably not very aware that we were doing it. Okay. So one of the things that we want to do with functions is we want to avoid duplicate code. Okay. So why do we want to avoid duplicate code? Well, first, we don't want to write the code twice. There's a lot of typing, right? The other thing is that we don't want to have to test it in two places. And the third thing, although only two of them are on the slide, is we don't want to have to maintain them in two places, which would mean if we have a change in what we want to do, say our requirements should change, not only would we have to change the code, but we'd also have to test the code. Okay? So one of the things that we can use to reduce the duplication of code within our programs is we can use functions. Okay? And they make programs easier to read, easier to write, easier to test, easier to maintain. We're looking for all four of those. Okay? So what's a function all about? Well, a function is like a little program or a subprogram. It's a little program part, a subprogram. The basic idea is we write a sequence of statements, and then we give that sequence a name. And then we can execute the sequence in any time by referring to the name. And we've had examples in my class between the lectures and the tutorials of extracting code out into a function and giving it a name. And we know that when we want to either call that function or invoke it, there are two different words that we use for the same thing. We simply type the name of the function into our program, and typically we follow it with double parens. And that's how we get it done. Double parens, a set of parentheses. That's what I mean. Okay, so the part of a program that creates a function is called a function definition. And we have had one of those for main, and again, in my class, we've created a couple of other functions. When the function is used in the program, we say that the definition is called or invoked. So here's an example that is used a lot in a number of courses and texts to illustrate repetitive behavior that we're used to, that we might find a way to get some efficiencies by using functions. Okay. For instance, let's say that we wanted to print the lyrics to Happy Birthday for our friend Fred. Well, we would put all the code into main, because that's what we've been doing. When we have larger programs, we tend to factor out some code into other functions. We're going to see a lot of that when we get to Chapter 9. But for the most part, we're not doing a whole lot in each of these sample programs, so we could put all the code into main. So if we wanted to print happy birthday to you, happy birthday to you, happy birthday dear Fred, happy birthday to you, we would just put 4 print statements in main, and then we would call or invoke main. And it would print out, as you see here on the slide. So there's some duplicated code here in the happy birthday to you, okay? And one of the things that we say is that why should we code that 3 or 4 times when we can code it once, we can put it in a function, and we can call that every time that we want to print happy birthday to you. So here on slide number 9, we have an example of creating a function called happy. And what's the code block that makes up happy? Well, just print happy birthday to you. Now, I'm just going to point out that, like many examples in the text, the name that we picked here for the function is, I think, adequate but not good. Okay? I might call it print happy birthday. Print birthday greeting. Say happy birthday. Okay? We don't have to have names for functions or variables that are short. We definitely don't want abbreviations. And we typically want a word or 2 or 3 that are really good at explaining, in the case of a function, what the function does without getting overly verbose. So for me, happy's too short. Okay? So with this function, we can rewrite our program. Now, I've mentioned this in the course before. What we're trying to do is something that we call refactoring. Okay? We have a program from the previous slide, and it gets the job done. All right? And we don't want to change the functionality. We just want to make the code easier to read, easier to test, easier to maintain. Okay? And when we change our code and don't change the functionality, that's part of a whole practice that's become very popular in programming, and it's a very good practice called refactoring. Okay, so what we're trying to do is to refactor this happy birthday lyrics in order to make use of a function that does the main lyric happy birthday to you. So let's go ahead to the beginning here. Okay, so let's do this. So we can say this. So we have a new program, okay, and we have one function called happy birthday to you. That was from before. And then we have a function called sing Fred, okay. And in sing Fred, we'd call happy, print happy birthday dear Fred, and we call happy again, okay? And then we'd say that we want to execute sing Fred. Now, one thing that I'm not particularly happy with here, happy being the word of the day, I guess, is that we called the top level code in our program, we called it sing Fred instead of main. Perhaps the author thought that this would be some subpart of an overall program, the top part of which would be called main, but we don't call the top code in our program in these cases anything else but main. Okay, so instead of def sing Fred, I would have said def main. Okay, and then I would have called main. So creating the function saved us a lot of typing. Okay, but it's not very general. Okay, it's not very general because if you've ever worked in a popular restaurant, you know that you're called upon to sing happy birthday quite often. And of course, you want to include the name of the person and hopefully get that right. Okay, so if you wanted to write a program, if you wanted to write some code to sing happy birthday to Lucy, well, then of course you'd have to recode it to call happy, and then print the message with the Lucy on it, and then call happy again. Well, it turns out that when we have things that are repetitive and we want to customize just a few aspects of it, there's a very good, powerful feature of functions that we can rely upon to do that. And that allows us to put more of our code into functions and get more power from them. Okay. So we could write a main program to sing to both Lucy and Fred. Oh, okay. So this is why he didn't use a main. He was saving that. Okay. So So he's saying, look, the work we want to do is to sing happy birthday to Fred, print a blank line, and then sing happy birthday to Lucy. Okay. And he could do that. Or maybe what we would like to do is to write a function that sings happy birthday to any person, and we're going to pass their name in as a parameter. Okay, and this is where the power comes in functions. Functions can take parameters. Let's take a look at that. Okay, so the generic function sing, okay, is called the function name is sing. We have something in the parens now. We've been having, anytime we deal with functions up until now, for the ones that we've created, we've had empty parens. Okay, well, what goes in the parens when they're not empty? Well, a parameter name. Okay? So, what's a parameter name? Well, in the code, in the function code itself, it's a special kind of variable. Okay? So, for instance, we can say, for instance, we can call happy, happy. We can print happy birthday, dear. And then we can use the name person in order to personalize it. And then we can call happy again. Okay? And how do we know what value the person parameter variable is going to have? Well, it's going to be set when we call it. So when we call sing, we're going to call it with an actual parameter or argument in the parentheses. So if we're calling a function that takes a parameter, okay, then when we call it, the parameters, the parentheses that come at the end of our call, they contain an actual parameter, and we're going to substitute that value for person when we get down to the function. Okay, so in this case, if we call sing Fred, we're going to get happy birthday to you, customized for Fred. So now we're going to do another main program, which I'm glad we got to, because you heard me complaining about the fact that we were putting code into something that wasn't a main. Okay, so we're going to code up in the main, we're going to code sing Fred, print a blank line, sing Lucy. Okay, that's good. Now, we haven't taken the room to show you the function sing because it's on the previous slide. Okay? I'm sorry. It's 2 slides back. All right? One of the things you'll see with courseware is that the authors don't have a lot of room. So sometimes we're not showing something, not because it's not there or we don't think it's important. It's just we don't have a lot of room. We wanted to show you the output. So when we call or invoke the function main, it calls sing twice, once with the actual parameter Fred, and once with the actual parameter Lucy. Okay. Okay. So in chapter 4, which we didn't cover in my class, we had done some things with the graphing program. And so since we didn't cover it yet, we're not going to go back and revisit an example that we didn't cover. Okay. So here on slide 20, we kind of come back again and get started. Okay. And there's a really important idea down here on bullet 2, and that is variables have this thing called scope. And up until now, when we've been putting all of our code into main, right, which is a single function, we haven't had to worry about variable scope before. As soon as we get multiple functions in a program, the question comes up that here's the question: what code can see which of the variables? Okay, the range of the program code in which a variable can be seen and can be referenced and used is referred to as its scope. So we're going to look at that in some practical terms. Okay, so each function is its own little subprogram. The variables used inside of a function are local to that function, even if they happen to have the same name as the variables that appear inside of another function. Okay, so the functions that we've created so far, to the extent that we create a variable in that function, that variable name is only known inside that function. So it has a scope that's limited to that function. So if we have a variable that came to life in main, well, it's only known within the scope of main. If we have a variable that came to life in the scope of inside of sing, then that variable is only known inside of sing. Incidentally, main and sing could each create variables of the same name, but they wouldn't be the same variable. They just would be two variables of the same name that have a different scope that refer to different things. Well, then how can code in a function get access to values from another function? Well, we've already seen how that happens. We do that through parameters. So the only way for a function to see a variable from another function is for that variable to be passed as a parameter. Okay? And that's what we did when we passed the name. Now, it wasn't a variable, it was a literal string. Okay? But they both refer to values, and it's the values that we're concerned about for the most part. Okay. So this one refers to chapter 4. We're not going to talk about that. Okay. So let's look at a function a little more formally, okay, and kind of analyze the features. So a function definition looks like this, okay. So we say def, and then we have the name. Put your name here, and then we have parens, and then we have 0 or more formal parameters. Okay, and then they go inside the parens. Then we have a colon that says we're introducing the body of the function, which is a code block. And then, of course, indented, we have the code that is the body of the code block. So the name of the function must be a valid Python identifier. So it's got to be one of the names that we've been using up until now for valid Python names. The formal parameters is a possibly empty list of variable names. Well, we've seen the empty. Why? Well, because we've defined main over and over again, and it doesn't have any formal parameters, and so it's empty. Okay. And we've seen sing, which has a formal parameter called person, which is a person's name. Okay, so we've seen one in which we have one formal parameter, and we've seen a lot of examples of main in which we have none, just empty parens. So formal parameters, like all variables used in the function, are only accessible in the body of the function. They have a scope limited to that function. Variables with identical names elsewhere in the program are distinct from the formal parameters and the variables that are inside the body of another function. Okay? Now this turns out to be really helpful. How so? Well, one of the helpful things is that there are times when you get inside of a function and there are some kind of go-to and names that you want to use, right? For instance, a name that I like to use a lot is answer or result, okay? That's because I'm going to return a value, which we'll get to in a bit. And I want to hold on to it till I'm ready to send it back to the calling code. Well, do I have to worry that maybe I used that variable name answer or result in another function? No, I don't, because each of the functions has its own namespace, if you want to use kind of technical terms. And so the variable answer in one function is a completely different variable from the variable answer in another function. And the only way to relate them is for one function to call the other and to pass the value as a parameter. That's the only way it can be done. So it becomes really easier to write functions because you don't have to worry about, well, have I already used these names? Well, no. When you use them inside of a function, you're using them in the context of that function. Okay? They're local. We say they're local to that function. Okay, so we've seen the definition of defining a function. Now, what does it look like? What's the code look like that calls a function? Well, a function is called by using its name followed by a list of actual parameters or arguments. Okay, so we just have the name. We have open and close parens, okay, and if the function takes arguments, or if it takes parameters, then we provide actual parameter names, okay. We say or arguments. Okay, now in some languages, like say the Java language, okay, there are two different terms, okay. When you're calling like this, we say that the names in the parens, the names on the list are arguments. They're variable names from your part of the program, okay. And then in the called code, the names that appear inside the parentheses are called the parameters, okay. Now, in Python, if you went to the formal definition for Python, I believe that the list that's on the calling code are called actual parameters, and the list that's on the called code are called formal parameters. Okay, so they're all parameters of a sort. A lot of us like to still refer to the list of names on the calling code as arguments, so as to distinguish them from the formal parameters that are in the called code. Okay. In this textbook and on this in these slides, we use actual parameters and arguments kind of interchangeably. And that's the way they kind of work in my head. So if I say arguments, think actual parameters. So the way that function calls operate, we've already seen it work. Okay. Well, we've seen it work in a very simple way with the call to main and all the programs that we created so far. We've seen it work in a more definitive way in the example that we just did with happy birthday, right? And so now what we're going to do is we're just going to walk through it a bit and give you the play-by-play of how things work in case you miss some of the finer points. Okay? So, we're in the calling program. We're in the calling code. The calling program suspends execution at the point of the call to a function. The formal parameters of the function get assigned the values supplied by the actual parameters in the call. Okay? They get assigned the values. Okay? The values are passed. They're passed by value. The body of the function that was called is executed. Control returns to the calling code to the point just after where the function was called. Okay? So let's trace through the following code. Sing Fred, print a blank line, sing Lucy. When Python gets to sing Fred, execution of main is temporarily suspended. Python looks up the definition of the sing function and sees it has one formal parameter, person. The formal parameter is assigned the value of the actual parameter. It's as if the following statement had been executed. Person equal Fred. It's like an assignment, okay? So here's a little more graphical version of that, more picture-oriented. So note that the variable person has just been initialized, okay? So there's a literal value in main that has the value Fred, okay? And then when we do the call and we pass that literal value Fred, what happens is that you can think of it that there's a variable called a person created in sing, and it's assigned the value Fred, okay? And it's a local variable. It's not visible in any other function. Okay. So the first thing that happens when we get to the called code to the function sing is there's an assignment of the literal Fred to a person. Okay, and then we're looking at the person variable after that. At this point, Python begins executing the body of the function sing. The first statement is another function call to happy. What happens next? Well, Python suspends the execution of sing and transfers control to happy. Happy consists of a single print statement, which is executed and control returns to where it left off in sing. So again, this is a little more graphical representation of it. Over here on the left, we say sing Fred. We go into sing, right? We call happy. Then we go into happy, we print happy, and then we come back to sing and do the next happy, go to sing, go to happy, go back to sing, then we print this and we go to happy, we do the happy thing again. When we're done with the end of sing, then we go back to right after sing Fred, when we go back to print a blank line, and then sing Lucy. We start this all over again. Okay. So when Python gets to the end of sing, control returns to main and continues immediately following the function call. Notice that the person variable in sing has disappeared. Now this is the interesting thing. When we call a function, we have these local variables in the function, and they have a very short life. They have the life of one invocation of that function. Okay? Sounds kind of wasteful, doesn't it? Well, it turns out that it's a way to, it turns out that it's a tried and tested scheme for programming language architecture. Okay? So functions have local variables, and the local variables are perishable. They only have a life for one invocation. Okay? And then they go away. They disappear. Okay? Now that keeps us from really hogging up the memory of the computer. Okay? So the memory occupied by local function variables is reclaimed when the function exits. Local variables do not retain any values from one function execution to the next. Okay? So sing doesn't really have a memory, right? It only remembers what it's supposed to be doing in the current invocation. It doesn't remember anything from previous invocations. So everything is brand new. Okay? Turns out that that's a pretty good scheme for things. The next statement is a bare print, which produces a blank line. Python encounters another call to sing, and control transfers to the sing function with the formal parameter Lucy. And now it's all over again. Okay, the body of sing is executed for Lucy with its 3 side trips to happy, and then control returns to main. Okay? Now that's kind of what we were seeing before, but we've given you the play-by-play. Well, this just kind of shows you what happened. So we say sing Lucy, we go over to sing, we run sing, which means we get 3 trips to happy, and then we come back, and if there's any code after sing Lucy, then we continue on there. I think in our actual code, there isn't any code after sing that's explicit, so we continue on to finishing the execution of the program and being done. Okay, one thing that is not addressed in this example was multiple parameters. In this case, the formal and the actual parameters are matched up based upon position. So the first actual parameter is assigned to the first formal parameter. The second actual parameter is assigned to the second formal parameter, etc. Now, there are other kinds of parameters in Python. There are things called keyword parameters, and we'll get to some experience with them before the course is out. But these positional parameters are the most commonly used. Okay? So they're matched up by position. So for instance, here we will actually look at this thing that relates to chapter 4. Here's a function called drawBar, and we drawBar when 0 principal. Okay, so I think what we're doing is that we're when is a poorly named variable that refers to the window that we're drawing in. 0 is a value, and principal is a value as well. So it's something that we want to draw a bar with. Okay. Okay. Good. The net effect is as if the function body had been prefaced with 3 assignment statements. here at the very end, I think we said, what if we called a drawbar window year height? Okay. The first thing that happens is that we assign win to window, 0 to year, principal to height. And again, this is maybe not the best choice of either actual or formal parameter names, because why window, I can see that. 0 to year seems kind of dangerous. Principal to height seems like they're two entirely different things. Okay. But what was it saying? Well, it's going to match up the actual parameters with the formal parameters based upon their order. Okay? And this is probably an example of in some unfortunate code where they're not matching up in the intended way. Why we would want whatever's in principle to be the height, I don't know. Okay, so that's it for part one. I've divided this into two parts, so the videos are about half as long. So I'll be back with part two, in which we'll be beginning with functions that return values. See you in part two. Bye-bye.